there's a planet in our solar system so enormous that every other planet could disappear tomorrow, and the solar system would still look familiar. Remove Mercury, remove Venus, remove Earth, Mars, Saturn, Uranus, Neptune. The sun would barely notice. But remove one planet, and the story changes completely. Not overnight, not with an explosion, not with some dramatic Hollywood disaster. Instead, the invisible architecture of our cosmic neighborhood begins to unravel, because one world has spent the last 4.5 billion years quietly shaping the destiny of everything around it, including us. When most people think about Jupiter, they picture a giant striped planet, a swirling red storm, maybe a few moons. Then they move on. But astronomers don't look at Jupiter that way. To them, Jupiter isn't simply the biggest planet. It's the reason our solar system became the solar system we know today. Its gravity has redirected wandering worlds, captured ancient moons, shaped the asteroid belt, disturbed comets traveling through deep space, and perhaps played a crucial role in giving Earth enough time for life to evolve. Without Jupiter, there's a chance you wouldn't be watching this video. There might never have been anyone to watch anything at all. Now here's something even stranger. For a brief moment in its distant past, Jupiter came surprisingly close to becoming something else entirely. Not another planet, a star, not a star like our sun, but a failed one, a world so massive that it exists on the thin boundary between planets and stellar objects, a cosmic giant that almost crossed the line, but never quite made it. That single twist of fate changed everything. And yet, for all its size, for all its power, Jupiter remains one of the least understood places in the solar system. No solid ground, winds faster than hurricanes, lightning storms larger than continents, pressure so immense that hydrogen itself transforms into something unlike anything naturally found on Earth. Dive too deep, and the laws of everyday experience begin to fall apart. There comes a point where the question is no longer, what would happen if you fell into Jupiter? The real question becomes, at what point would Jupiter stop behaving like a planet altogether? Every spacecraft that has visited Jupiter has returned with surprises. Voyager, Galileo, Juno, each mission peeled back another layer, only to reveal a planet more mysterious than anyone expected. A world that refuses to fit neatly into our definitions. Too large to ignore, too complex to fully understand. So today, we're not just exploring the solar system's largest planet. We're uncovering the hidden story of the giant that quietly shaped the fate of every world around it. We'll travel into storms older than human civilization, descend toward an interior no spacecraft has ever seen, visit oceans hidden beneath frozen moons, and discover why some scientists believe the most promising place to search for alien life isn't a planet at all. It's a moon orbiting Jupiter. By the end of this journey, you may never look at the night sky the same way again, because Jupiter isn't simply another stop on a map of the solar system. It's the invisible force that has been influencing our story since long before the first oceans formed on Earth. And once you understand what Jupiter has been doing all this time, you'll realize something extraordinary. The biggest planet in our solar system may also be its greatest guardian. For thousands of years, people had no idea what Jupiter really was. To ancient civilizations, it was simply one of the brightest lights in the night sky. The Babylonians watched it move among the stars with remarkable precision. The Greeks associated it with Zeus, king of the gods. The Romans renamed it after Jupiter, the ruler of their own pantheon. Even without telescopes, people sensed that this wandering point of light was somehow different, brighter, slower, more commanding. It seemed to dominate the heavens in the same way kings once dominated kingdoms. Oddly enough, they weren't entirely wrong. Today, we know Jupiter isn't just another planet. It's the largest object in the solar system besides the sun itself. If you gathered every planet together, Mercury, Venus, Earth, Mars, Saturn, Uranus, and Neptune, then combined all of their mass, Jupiter would still account for more than twice as much. Think about that for a second. One planet outweighs every other planet combined. That's almost difficult for the human mind to accept, because our brains aren't built to imagine worlds on this scale. Let's try another comparison. Imagine the solar system as a family photograph. The sun stands in the center, towering above everyone else. Around it are 8 children. 7 of them are standing together on one side. Then there's Jupiter, standing alone. Despite standing by itself, it's still heavier than the other 7 combined. Suddenly, the picture changes. Jupiter isn't just the biggest sibling. It's almost in a category of its own. Its diameter stretches nearly 143,000 kilometers. You could line up about 11 Earths side by side across Jupiter's face. Inside its volume, more than 1,300 Earths could fit. That number appears in countless documentaries. But numbers have a strange weakness. They're easy to hear and easy to forget. So let's picture it differently. Imagine flying toward Jupiter aboard a spacecraft. At first, it looks much like every other planet you've seen in photographs. A colorful sphere floating in darkness. Hours pass. The planet grows larger. Another day passes. It grows larger still. Then something unusual happens. You begin realizing that the horizon never seems to get closer. Jupiter keeps expanding in your window, not because it's approaching unusually fast, but because it's simply enormous. What looked like a distant marble slowly transforms into an entire world stretching beyond your field of view. Astronauts who flew past Earth during the Apollo missions described our planet as breathtaking. Flying toward Jupiter would be something else entirely. It wouldn't feel like approaching a planet. It would feel like approaching a landscape suspended in space. Yet despite its incredible size, Jupiter is surprisingly light. Not in total mass, of course. It's more massive than every other planet combined. But compared to its size, it's strangely low in density. Drop Earth into a giant imaginary ocean, and it would sink. Drop Saturn, and it would float. Jupiter sits somewhere in between. Its average density is only slightly greater than water. That seems impossible until you remember what Jupiter is actually made of. Unlike Earth, there are no continents, no mountains, no oceans, no solid surface waiting beneath the clouds. Jupiter is made primarily of hydrogen and helium, the same elements that make up the Sun. The difference is that Jupiter never accumulated enough mass to ignite nuclear fusion. It gathered almost everything needed to become a star, except the final ingredient, enough gravity. This is why astronomers sometimes call Jupiter a failed star. It's a dramatic phrase, but it can also be misleading. Jupiter was never close to becoming a star like our Sun. To ignite hydrogen fusion, it would need roughly 80 times its current mass. That's an enormous difference. However, there's another class of object known as a brown dwarf. Brown dwarfs exist in the strange middle ground between planets and stars. Some can briefly fuse deuterium, a heavier form of hydrogen, without ever becoming true stars. Jupiter would still need to be much more massive to reach even that threshold. So while failed star makes for a memorable nickname, it's more accurate to think of Jupiter as the largest planet nature could build without crossing into a completely different category. And in many ways, that's even more fascinating, because Jupiter sits right on the edge of something extraordinary. Then there's another misconception. People often imagine Jupiter as peacefully orbiting the Sun, almost like a giant spectator watching the rest of the solar system. In reality, Jupiter is constantly pulling on everything around it. Its gravity reaches astonishing distances. Asteroids, comets, neighboring planets, even the Sun itself. Here's something many people don't realize. The Sun doesn't remain perfectly still while Jupiter orbits it. Instead, both objects orbit a shared center of mass called the barycenter. Sometimes that point actually lies just outside the Sun's surface. Think about what that means. Jupiter is so massive, it makes the Sun wobble. Not by much, but enough that astronomers use the same principle to discover planets orbiting distant stars. Thousands of exoplanets have been detected because giant planets make their parent stars perform tiny, measurable dances across space. In a strange way, every exoplanet discovered through stellar wobble owes part of its story to what Jupiter taught us. But Jupiter's influence reaches much farther than astronomy textbooks. Billions of years ago, our solar system looked nothing like it does today. There were no stable planetary orbits, no familiar arrangement of worlds, just chaos. Dust collided with dust, rock struck rock, small worlds grew larger, large worlds migrated. Gravity constantly reshaped the young solar system. Many scientists now believe Jupiter itself didn't form where we see it today. Instead, it may have migrated inward toward the sun before reversing direction and moving outward again. This idea is known as the Grand Tack hypothesis. The name comes from sailing. A sailboat changing direction against the wind performs a maneuver called a tack. According to this hypothesis, Jupiter performed something remarkably similar. It began moving inward, then Saturn formed. The two giants became gravitationally linked. Together, they changed course. That single reversal may have prevented Jupiter from destroying the inner solar system. It may also explain why Mars is surprisingly small compared with Earth and Venus. Without Jupiter's migration, our solar system could have looked completely different. Perhaps there would be no Earth as we know it. Perhaps Mars would have become another Earth-sized planet. Perhaps none of us would be here asking these questions. This is where Jupiter stops being just another fascinating planet. It becomes a cosmic architect, not because it intended to shape anything. Gravity has no intentions. It simply follows the laws of physics. Yet over billions of years, those invisible forces sculpted entire worlds, including our own, every orbit, every asteroid, every comet that narrowly missed Earth, every ancient collision that helped build the planets. Jupiter's fingerprints are everywhere, even when we don't notice them. When we look at Jupiter through a telescope, it's easy to admire the colorful bands wrapping around the planet, the swirling clouds, the famous Great Red Spot. It looks peaceful, almost elegant, but appearances can be deceptive because beneath those beautiful clouds, winds are racing faster than the speed of sound. Storms have been raging longer than human civilization has existed. Lightning flashes with unimaginable power, and deeper still, the very nature of matter begins to change. Jupiter isn't just large, it is violent, beautiful, and unlike anything else in the solar system. From millions of kilometers away, Jupiter looks calm. Its bands of white, orange, and brown wrap perfectly around the planet like carefully painted brushstrokes. Even the Great Red Spot appears almost elegant. If you didn't know better, you might think you were looking at a giant marble floating peacefully through space. But beauty has a way of hiding violence. And nowhere is that more true than here, because beneath those graceful cloud tops lies an atmosphere in constant motion. There are no quiet seasons, no calm oceans, no stable skies. Every second, somewhere on Jupiter, another storm is forming. On Earth, we often describe hurricanes as some of the most powerful forces in nature. Satellite images show entire coastlines disappearing beneath swirling clouds. Cities prepare for days. People evacuate. When a Category 5 hurricane arrives, it can reshape landscapes in a matter of hours. Now imagine taking that hurricane, making it several times larger than Earth, allowing it to spin continuously for centuries, and placing it inside an atmosphere with no continents to slow it down. You're beginning to understand Jupiter. The most famous storm in the solar system has a name that almost everyone has heard, the Great Red Spot. Astronomers have been watching it for more than 300 years. Think about that for a moment. When Isaac Newton was still alive, the storm was already there. When the American Revolution began, it was still there. When the Wright brothers flew the first airplane, it was still there. Through every empire, every scientific breakthrough, every generation of human history, that storm kept spinning, relentlessly, silently, patiently. Nobody knows exactly when the Great Red Spot first formed. Some historical observations suggest it may have existed even before telescopes became sophisticated enough to study it properly. If that's true, the storm may be far older than 3 centuries. It could have been raging long before modern science even had a name for planets. That's an astonishing thought. Entire civilizations have risen and fallen, while one storm refused to disappear. The storm itself is enormous. Although it has gradually been shrinking over the past century, it remains vast enough to swallow Earth, and that's after becoming significantly smaller than it once was. Older observations suggest that in the 19th century, nearly 3 Earths could have fit inside it. Today, it would only fit about 1. It's strange to describe a storm larger than our planet as getting smaller. Only Jupiter makes that sentence sound reasonable. Scientists still debate why the Great Red Spot has survived for so long. On Earth, storms eventually lose energy. They move over land. They encounter colder water. They collide with other weather systems. Eventually, they weaken. Jupiter offers no continents, no mountain ranges, no forests, nothing to interrupt the flow. Storms can continue feeding on the planet's internal heat for extraordinarily long periods. Instead of dying, they evolve. Sometimes they merge. Sometimes they split apart. Sometimes they simply continue spinning for generations. And the Great Red Spot isn't even the only storm. Far from it. Jupiter's atmosphere resembles an entire planet covered by jet streams. Powerful winds race eastward. Others move westward. These bands slide past one another at tremendous speeds, creating turbulence on a scale unlike anything found on Earth. From orbit, the atmosphere almost resembles flowing liquid, but it's gas. Layer upon layer gas, moving constantly, never truly resting. Wind speeds regularly exceed 600 kilometers per hour. To put that into perspective, many commercial airplanes cruise at speeds not dramatically higher than that. Imagine standing inside a wind tunnel where the air moves almost as fast as a passenger jet. Now imagine that wind never stops. Not today, not tomorrow, not a century from now. That is simply normal weather on Jupiter. Then there is the lightning. On Earth, lightning is one of nature's most spectacular displays. A single bolt can briefly heat the surrounding air to temperatures hotter than the surface of the sun. Now, picture thunderstorms occurring inside clouds that stretch for hundreds of kilometers. NASA's Juno spacecraft revealed lightning flashes concentrated near Jupiter's poles, surprising scientists who once expected them near the equator. Some of those flashes release far more energy than the typical lightning strike on Earth. If you could witness one from a safe distance, the sky would erupt in brilliant white light. Not once, but over and over again, a planet conducting an endless electrical symphony. As spectacular as Jupiter appears from above, its greatest secrets lie beneath the clouds. Those colorful bands aren't painted onto a surface. They're only the visible skin of an atmosphere that extends astonishingly deep. At first, the clouds seem almost familiar. The highest layers are composed largely of ammonia ice crystals. Below them, ammonium hydrosulfide. Farther down, water clouds. Meteorologists on Earth study weather systems that reach perhaps 20 kilometers into the atmosphere. Jupiter's weather extends thousands of kilometers downward. It isn't simply weather. It's an entire planetary engine. The deeper you descend, the stranger everything becomes. Pressure increases steadily. The air grows denser. The sunlight fades. Cloud layers stack above one another until daylight becomes little more than a distant memory. Eventually, the atmosphere becomes so thick that flying through it will feel less like moving through air and more like diving beneath an ocean. Except this ocean isn't made of water. It's made of compressed gas. And this is where many illustrations become misleading. They often show Jupiter with a clearly defined surface hidden beneath the clouds, as if eventually you'd land on solid ground. In reality, no one knows exactly where the atmosphere ends and the planet begins, because there may not be a clear boundary at all. The gas simply becomes denser and denser until it behaves like an entirely different state of matter. It's one of the few places in the solar system where the familiar distinction between sky and ground begins to lose its meaning. Imagine falling toward Jupiter. At first, the experience might almost seem peaceful. The upper atmosphere is cold and thin. Sunlight still filters through the clouds. Then the winds begin pushing you sideways. Violently, you descend farther. Pressure doubles, then doubles again. Clouds become darker. The temperature climbs. The air becomes almost impossible to recognize. By now, Your spacecraft is no longer flying through weather. It's entering a world where weather never ends. Long before reaching the deepest layers, the crushing pressure would overwhelm almost any machine humanity has ever built. Even spacecraft specifically designed to explore Jupiter survive only briefly after entering its atmosphere. NASA's Galileo probe intentionally plunged into Jupiter in 1995. It transmitted data for just under an hour before the pressure and heat became too extreme. That lone spacecraft remains the deepest direct exploration humanity has ever achieved inside a gas giant. Everything below that point is inferred through physics, computer models, and observations made from afar. In other words, there are places inside Jupiter that no human technology has ever seen. The deeper scientists look, the more unusual Jupiter becomes. Hydrogen, the simplest and most abundant element in the universe, begins behaving in ways that seem almost impossible. Under unimaginable pressure, it transforms, not into a solid, not into an ordinary liquid, but into something called metallic hydrogen, a substance that doesn't naturally exist anywhere on Earth, one that conducts electricity like a metal while remaining fundamentally hydrogen. It's this bizarre ocean of metallic hydrogen that helps generate Jupiter's astonishing magnetic field, a force so immense it traps radiation belts far more intense than those surrounding Earth. We'll come back to that mystery later, because what happens inside Jupiter doesn't stay inside Jupiter. Its hidden interior shapes the space around the entire planet. Perhaps that's what makes Jupiter so captivating. Every answer leads to another mystery. You begin by asking why the clouds are striped. Soon you're discussing electrical oceans made of hydrogen. You wonder how storms survive for centuries. You end up questioning where a planet actually begins. Jupiter has a remarkable habit of stretching our definitions, not because it's trying to confuse us, but because nature built something far stranger than anyone expected. If Earth teaches us what a habitable world looks like, Jupiter teaches us what happens when nature keeps building, larger, hotter, deeper, more powerful, until the familiar rules no longer seem quite so familiar. And yet, despite all its violence, all its unimaginable pressure, and all its endless storms, Jupiter is not the most extraordinary thing in its own system, because circling this giant are worlds that may hold oceans beneath frozen shells, worlds where sunlight never reaches the sea. Yet life might still find a way. The greatest mystery of Jupiter may not be Jupiter at all. Long before anyone knew what Jupiter really was, another mystery was waiting to be discovered, not on the planet itself, but around it. On a cold January night in 1610, an Italian mathematician pointed a small telescope toward Jupiter. The telescope was primitive by today's standards. Its lenses distorted light. Its magnification was modest. By modern standards, it was little more than a toy. Yet what Galileo Galilei saw through that instrument would permanently change humanity's understanding of a universe. At first, he noticed 3 tiny points of light sitting beside Jupiter. Nothing unusual, perhaps distant stars. But something bothered him. The next evening, their positions had changed. A few nights later, they had moved again. Stars don't behave like that. Night after night. Galileo continued observing them. Eventually, a 4th point appeared. Slowly, the pattern became impossible to ignore. These lights weren't orbiting Earth. They weren't fixed to the heavens. They were circling Jupiter. It was the first direct evidence that not everything in the universe revolved around our planet. That single observation dealt a devastating blow to the old geocentric model that had dominated European thought for centuries. Sometimes history changes because of wars, sometimes because of revolutions, and sometimes because 4 tiny lights refuse to stay still. Today, we know those 4 worlds as the Galilean moons: Io, Europa, Ganymede, Callisto. Simple names. Yet each one is stranger than the last. Together, they transform Jupiter from a lonely giant into the center of an entire planetary system. In fact, if Jupiter were somehow replaced by a small star, its largest moons would almost resemble planets orbiting their own sun. The scale is extraordinary. More than 95 confirmed moons have been identified around Jupiter, and astronomers continue discovering tiny irregular satellites as observations improve. Some are only a few kilometers across. Others are larger than planets. Each one tells a different chapter of Jupiter's story. If Mars is quiet, Io is the complete opposite. This moon is the most volcanically active world ever discovered, not just in Jupiter's system, in the entire solar system. More than 400 active volcanoes have been identified. Some eruptions launch material hundreds of kilometers above the surface. Seen from space, towering plumes rise like ghostly fountains against the darkness. From orbit, Io looks almost unreal. Its surface glows with shades of yellow, orange, black, and deep red. It resembles molten artwork more than a natural world. Those colors come largely from sulfur and sulfur compounds, continually recycled by volcanic eruptions. The landscape is constantly rewritten. Lava floods old plains. New mountains rise. Fresh deposits blanket ancient terrain. Unlike Earth's surface, which changes over millions of years, Io can transform dramatically in just a few decades. So, where does all that energy come from? The answer isn't hidden beneath Io. It's written in gravity. Every time Io circles Jupiter, the giant planet stretches and squeezes the moon, not by a few centimeters, by as much as 100 meters. Imagine taking a rubber ball, compressing it, releasing it, then repeating the process endlessly. The constant flexing generates heat inside Io's rocky interior. Scientists call this tidal heating. It's one of the most remarkable engines in planetary science. Io isn't powered primarily by radioactive decay like Earth. Its volcanoes are fueled by Jupiter's relentless gravitational pull. The moon is literally being kneaded from the inside out. Now leave Io behind. Travel outward. The landscape changes completely. Gone are the glowing volcanoes. Gone is the chaotic sulfur. Ahead lies a smooth, brilliant world wrapped in ice. Europa, at first glance, it looks almost lifeless. A frozen sphere crisscrossed by dark fractures stretching for thousands of kilometers. Few impact craters interrupt the surface. That alone tells scientists something remarkable. Europa is constantly renewing itself. Its icy shell isn't ancient and static. It's alive with movement, cracking, shifting, slowly reshaping itself over time. But the ice isn't what excites scientists. It's what's beneath it. Evidence collected over decades suggests Europa hides a global ocean beneath its frozen crust. Not a small underground lake. An ocean, one that may contain more liquid water than every ocean on Earth combined. Pause for a moment and think about that. One small moon, orbiting a gas giant nearly 800 million kilometers from the Sun, may contain the largest reservoir of liquid water in the inner reaches of our solar system. And almost none of it has ever seen sunlight. That immediately raises an astonishing possibility. On Earth, wherever we find liquid water, we almost always find life, not necessarily complex life. Sometimes only microscopic organisms. But life has proven extraordinarily adaptable. Microbes thrive near deep-sea hydrothermal vents where sunlight never reaches. They survive inside Antarctic ice, within solid rock kilometers underground, in environments once thought completely sterile. If life can flourish in those extreme places, could Europa's hidden ocean also be habitable? No one knows, but it has become one of the most compelling questions in modern astronomy. That's why NASA is preparing the Europa Clipper mission to investigate whether this frozen moon possesses the conditions necessary for life. It won't search directly for organisms. Instead, it will study the chemistry, ice shell, and possible exchange between the ocean below and the surface above. Sometimes, understanding whether a world could support life is the first step toward discovering whether it ever did. Continue farther from Jupiter, and another surprise appears. Ganymede, the largest moon in the solar system. It's bigger than the planet Mercury. If it orbited the Sun independently instead of Jupiter, many people would simply call it a planet. But size isn't what makes Ganymede extraordinary. It's the only moon known to possess its own intrinsic magnetic field. That might sound like a technical detail. In reality, it's astonishing. Magnetic fields require active interiors, movement, energy, complexity. Ganymede isn't just a frozen ball of rock and ice. It's a dynamic world with metallic core generating an invisible shield around itself. Even while orbiting inside Jupiter's immense magnetic environment, Ganymede maintains one of its own. Planetary scientists continue studying how such a system evolved. The moon keeps challenging expectations. Then comes the oldest face in Jupiter's kingdom, Callisto. Unlike Europa, its surface has remained largely unchanged for billions of years. Impact craters overlap one another in every direction. Some are so ancient that newer craters form directly on top of them. Looking at Callisto is like opening a geological time capsule. If Earth constantly rewrites its story, Callisto almost never edits its own. Every impact, every scar, every collision remains preserved. It offers scientists a rare glimpse into the violence of the young solar system. In many ways, Callisto is less a destination and more an archive. Something remarkable happens once you step back. Jupiter stops feeling like a single planet. Instead, it resembles a miniature solar system, a giant world at the center, dozens upon dozens of moons orbiting around it, each with unique histories, unique geology, unique chemistry, unique possibilities. Some burn with volcanoes, others hide oceans. Some preserve the earliest history of planetary formation. Others continue evolving today. No two are alike. Imagine shrinking yourself until Jupiter fills the sky above you. Night falls on Europa. Far overhead, Jupiter hangs hundreds of times larger than our moon appears from Earth. Its cloud bands slowly rotate across the darkness. The great red spot becomes visible to the naked eye. Auroras shimmer around its poles. The giant dominates the heavens so completely that it no longer looks like a planet. It looks like a second sky. That view alone would change your understanding of the word moon. Perhaps that's Jupiter's greatest achievement. Not its size, not its storms, not even its gravity. Its ability to create diversity. One giant planet, surrounded by worlds that seem determined to prove there is no single blueprint for how planets or moons should evolve. Each one asks a different scientific question. Each one invites a different mission. And each one reminds us that the solar system is far richer than early astronomers ever imagined. When Galileo first discovered 4 tiny points of light beside Jupiter, he couldn't have known what they truly were. He saw moving dots. We see oceans hidden beneath ice, volcanoes reaching into space, magnetic fields, ancient scars, possible habitats for life. The same 4 lights, yet an entirely different universe of understanding. That's the remarkable thing about exploration. The objects themselves rarely change. Only our ability to understand them does. And just when it seems Jupiter couldn't become any more extraordinary, another invisible force enters the story. One so vast, it stretches millions of kilometers into space. A magnetic field powerful enough to trap deadly radiation, generate auroras larger than entire planets, and shape the environment around every moon that dares to orbit too close. Because Jupiter doesn't end where its clouds disappear. In many ways, its true size begins where we can no longer see it.